In this video, we're going to see how Treasury bills are priced. We saw in an earlier video that that bond dealers will use something called the yield on a discount basis and quote that rather than the price. Well, how do we take that? First of all, what does that number mean? And how do we take that number and convert it to dollars and cents? We're going to be learning that. And again, it might be helpful for you if you're following along on the class notes that are titled Invoice Prices and T-bill Quotes. And it should be on the second page of that notes would be some of the examples and so forth that we're going to go over. So let me pull up a whiteboard so I can kind of show you what we're talking about here. As you know, a Treasury bill doesn't have any coupon payments. So let's take a Treasury, and we also know that it matures 1 year or less from the time it is issued. So let's take an example of a Treasury bill that's going to be maturing in 90 days. Doesn't matter if it's just now been issued or if you're buying it currently and it was issued a while ago. But here's the time line right here. Time zero is today, and it's maturing in 90 days. And let's suppose when it matures, again, this is the simplest way to do things for convention. This could be $1 million Treasury bill, face value of $1 million, face value of $100,000, $500,000, 250, lots of different face values. So we're going to make life easy by making the face value 100. And whatever it actually is, we just say this is 100% of that number. It makes life a lot easier when you're quoting things. So if that is the face value is 100, then the price today, let's say, is 99, which means again the price is 99% of the face value. Now there's no coupon payments anywhere in here because there's never a coupon payment on a Treasury bill. So how would you quote the yield on a discount basis? The yield on a discount basis is going to be quoted this way. It's going to be 100 minus the price of the bond, and we don't know what the price of the bond is, or do we do? The price is 99. 100 minus the price divided by 100, okay, multiplied by 360 over n. Now, that's going to be equal to the yield on a discount basis. And the yield on a discount basis, we're going to say, we're just going to call that D for right now, yield on a discount basis. That's what the price dealer, that's what the bond dealer will quote. So the way we're going to calculate that is that in this particular bond, that's going to be 100 minus 100 minus 99 is the current price, divided by 100 multiplied by 360 over n. N is the number of days until it matures, and that's 90. Okay, and so that is going to be equal to 4%. So the bond dealer would say, if you asked him what's the price on the bond, he's going to say 0.04 or 4%, because that's the yield on a discount basis. And you then have to figure out that the price is actually $99. Now, we see on this yield on a discount basis, this is not the correct way to calculate a yield. There are two mistakes that have been made here, but they've been made deliberately to make life a little bit easier. If you want to calculate a yield, it's going to be how much you made divided by how much was invested. And what was invested was the price, not the face value of here. But what's easier, to divide by 99 or to divide by 100? It's easier to divide by 100. Secondly, in terms of the days here, okay, how many compounding periods do we have? There's not 360 days in a year. There's 365 days in a year. Most of the time, some years there's 366 days in the year, right? But it's easier to do math with 360 in the numerator than with 365 or 366. So yield on a discount basis deliberately makes these two mistakes, if you will, in there to make it easier to calculate this value of D than it would be to calculate a yield. Well, why would they do that? Well, you have to remember that bonds and Treasury bills have been traded for a long time, okay, for decades and decades and decades, longer than there have been calculators and Excel and things such as that. So bond dealers for many years had to do this with pencil and paper or in their heads, and as a result, there were some shortcuts that were done in there to make it a little bit easier for them, and they just haven't been changed since then. So we just have to understand it. So 4% would be the yield on a discount basis. Now, how would you actually calculate the yield to maturity on this, the yield to maturity or the bond equivalent yield? Well, you correct the two mistakes that are there in the yield on a discount basis. The yield to maturity would be 100, okay, minus the price divided by the price instead of divided by 100, multiplied by the number of days in a year. We'll say 365 over n. And that's going to give us the yield to maturity. In our example, where the price is 99 and n is n is 90, that's going to give us that's going to be equal to 4.097%. Now, the yield on a discount basis is always going to be smaller than the yield to maturity, because when we switch from yield on a discount basis to yield to maturity, we're changing 360 to 365, which is in the numerator. That's going to make it bigger for yield to maturity mathematically. Also, we're changing from 100 to the price in the denominator, and the price, since these are sold at a discount, it has to be lower. That also increases the answer. So this number, the yield to maturity, is always going to be greater than this right here, right? So we understand now why they're calculating yield on a discount basis to make life a little bit easier for the bond dealers. How do we find P then? If we hear the yield on discount, how do we find P? Well, what we need to do is we're just going to say, and there's a little bit of algebra to get to this, but we simply say the price is going to be equal to 100 multiplied by 1 minus n over d divided by 360. So if I want to know what the price is, I need to know what is n, the number of days until maturity. In this case, it's going to be 90. I need to know what d is. D is the yield on a discount basis. In this case, it's 0.04 or 4%. Do the math on that, and then that will give me the price, which in this case would be, in fact, 99. Now, in your notes, it also talks about calculating an effective annual rate. I wouldn't worry about that. Let's just focus on yield on a discount basis and the yield to maturity, how we get that. And understand that for yield on a discount basis, we're going to divide by 100, and we're going to use 360 days in a year. On yield to maturity, we divide by the price, and we have 365 days in a year. So if I am given the yield on a discount basis and I want to find the price, I can get it with this right here. Now, there's one little tiny blip in this whole thing, and that is this. This works when there is 6 months or less until maturity. As we know, Treasury bills, when they're issued, can be 3-month Treasury bills. They can be 1-month Treasury bills, 3-month Treasury bills, 6-month Treasury bills, and 1-year Treasury bills. For 1-month Treasury bills, 3-month Treasury bills, and 6-month Treasury bills, everything I've shown you works all the time. For a 1-year Treasury bill, this works once we get to the point that there's 6 months or less until maturity. When a Treasury bill has got when a 1-year Treasury bill has more than 6 months till maturity, in other words, this time from 0 to out here is more than 180 days. Let's say it's 110 days or 120 days, something like that. This formula won't work. And the reason why it won't work is because we're trying to make the Treasury comparable to a Treasury bond. That's why we call it a bond equivalent yield. And with a regular old treasury bond, you never go more than 6 months without a coupon payment. With a regular treasury bond, you can go 90 days without any coupon payments because coupon payments are made once every 6 months. You can go 100 days, you can go 120 days, but you can't go more than 6 months, more than 180 days without a coupon payment. So in order to incorporate that difference, okay, there's a somewhat complex formula that I'm not going to hold you responsible for, but I think you might want to make yourself aware of it nonetheless. And so it's on your notes here, which I'll share with you. And it's right at the very bottom, last place on there, that here we go. This is it right there. That's the formula to find the yield to maturity. Bond equivalent yield means the same thing when there is more than 180 days until the treasury bill matures. Again, that will only happen for a 1-year treasury bill during its first 6 months, and I won't run that situation. I won't run you into that situation, but it's good to know. And I mean, it's just a matter of doing math, so it's not. I mean, there's a lot to it there, but it's just a matter of doing math. So treasury bills will have 1 month, 3 months, 6 months, or 1 year to maturity when they are issued. They make no coupon payments anywhere along the way, so they're always purchased at a discount. So if they mature for 100, you buy it for 99 or 98 or 98.5 or something like that. That's how you make your money. And then also, if you want to ask a bond dealer what is the price on a treasury bill, the bond dealer will quote you the yield on a discount basis. The yield on a discount basis is an approximation of the yield to maturity, where instead of having the true number of days in a year, 365, you have 360. And instead of putting the price in the denominator, we put 100 in the denominator. So that's what we need to know about the treasury bills and how they are priced. In our next session, we're going to look at some of this stuff in Excel.